So we're going to be doing arc length and area of a sector today. Okay, so arc length and area of a sector are nothing more than pieces of the circumference or the area. Okay, so for arc length we use S equals theta r, and for area of a sector we use 1/2 theta r squared. Now the other thing we have to remember is theta has to be in radians. Okay, so whatever we do, theta has to be in radians. So for number one, find the length of the arc of a circle with a radius of 5 and a central angle of 210 degrees. So it's asking me to find length. So as soon as I see length, I know I'm using arc length. So S equals theta r. Now again, the first thing I have to do is I have to change, since they gave me theta in degrees, I have to change it to radians. So 210 degrees times pi over 180 degrees, which is 210 theta over 180, which reduces down to 7 pi over 6. Well, now that I know what theta is, we just plug it in. So 7 pi over 6 times the radius, which is 5. So we get 35 pi over 6. And that's our answer. Okay, and we're going to leave it like that. I mean, technically that's like approximately 18.33. Okay, but we're going to leave it with pi in it because that's an exact answer versus rounding. Okay, it's that simple. We're just plugging in and finding what we need to find. So the second one, it says find the length of the radius of a circle. So we're trying to find the radius, and they give us an arc length of 10 and a central angle of pi over 6 radians. So as soon as we see arc length in here, we know we're using this equation. Now, they've given me the arc length, so S is 10. And theta, they've given me that as well, and that's pi over 6. So we're trying to find the radius. So we got to work it backwards. So 10 equals pi over 6 times r. Okay, so that means we got to get r by itself. So I'm going to multiply both sides by the reciprocal of pi over 6. So 6 over pi times 6 over pi. So that means I'm left with 60 over pi equals my radius, which again, if we approximate it, we plugged it into a calculator, it would be approximately 19.0985. Something. But we'll leave it as just r is 60 over pi. Okay? Because we want exact answers. All right, the third one. Find the area of a sector with a circle, a radius of 7, and a central angle of 50 degrees. So as soon as I see area of a sector, I know which equation I'm using, this one, 1/2 theta r squared. Okay, they've given me the radius, r is 7, and my central angle is 50 degrees, so theta is 50 degrees, but remember we have to have theta in radians. So we multiply by pi over 180, and we get 5 pi over 18. Okay, so now we just plug in. So we get 1/2 times 5 pi over 18 times r squared, which is 49. And then we multiply straight across, so 49 times 5, which is 245 pi, and then 18 times 2, which is 36. So that's our answer, which again, if you want to approximate, is 21.3802. Okay? So again, nothing too crazy, nothing too difficult. Number 4, find the central angle of a sector. So as soon as you see that sector, and then we say an area of, so they've given me the area. So I know I'm using my area equation. So my area is 1/2 theta r squared. And the distance from a point from the center is 3 centimeters. Well, that's a fancy way of saying that that's the radius, because from the center to a point, that is your radius. Okay, So we know our radius is 3. And we know what the area is. So we're working this one backwards to find the angle. So we plug in our area, which is 9 pi over 5 equals 1/2 theta, and 3 squared is 9 times 9. Okay? So when you multiply 9 times 1/2, you get 9 halves. So I'm going to multiply both sides by 2 over 9, which is the reciprocal. If you want to do it the long way and divide both sides by 9 first and then multiply both sides by 2, knock yourself out. But this divides out with that, leaves me with theta. And over here, 9 divides out with 9, and this divides both by 2, which leaves me with pi over 2. And that's my answer, which is basically 90 degrees. Okay? So the last one, which is probably the most difficult one because you have to think about it. Okay? So it says, what is the distance traveled by the tip of the second hand after 45 seconds if the second hand is 5 inches long? So I always tell my kids the first thing you do when you get to a word problem is draw a picture. So I have a clock. So 12, 3, 6, 9. Okay? And the second hand, they don't mean like the second one. They mean the second hand that counts the seconds. They say that is 5 inches. So from the center, I'm going to have it coming right here. This is 5. Okay? Now, it's traveling for 45 seconds. So what is my angle? And don't you dare say the angle is 45 seconds. So let's think about this. If this hand, which is 5 inches long, travels for 45 seconds, if it starts here at 12, it's going to go around for 45 seconds. Where does it end up after 45 seconds? Well, it ends up right here at 9. So what is this angle right here? Because we're trying to find how far this tip, this part right here, goes around. If we follow it, it goes around like this to get to here. So we're looking for this distance traveled around. Well, what's this angle? Well, we know that basically this is a 90-degree angle, this is 90, and this is 90. So 90 plus 90 plus 90 is 270 degrees. So it's gone around 270 degrees in 45 seconds. That is my angle. We're also talking about distance. So as soon as I see a distance and not area, I know I'm dealing with this, my arc length. So we're trying to find this length, the distance. So we're using this equation. So now that we've drawn a picture and figured things out, we know what r is. It's 5 inches. We know what our angle is. It's 270 degrees. But again, we can't leave it at 270 degrees. We have to find it in radians. So again, we're doing the same thing. We're getting it into our radians. So degrees, which is 270 pi over 180, which is 3 pi over 2. So that's our radians. Now we just plug in. So 3 pi over 2 times 5, which is 15 pi over 2 inches, which is the same thing, approximately 23.56 inches. Okay? So the hardest part about this was just drawing our picture, making sure that our picture was correct. As soon as we got our picture correct, then the rest of the stuff just fell in line.